Here's the strange thing about AI agents right now. They can write your code, they can run commands on your machine, and they can read half the internet for you. But not one of them can pay for anything. Today, we are going to fix that. By the end of this video, an agent on your laptop will own a wallet with a real address that anybody can look up, and you will know exactly where its private key lives and who is allowed to touch it. Before we type anything, let us get the one idea that everything else rests on. A wallet is not an app, and it is not a place where coins are kept. A wallet is a keypair, which just means two halves that belong together. One half is the address, and that half is public, so you can hand it to anybody like an account number. The other half is the private key, and that half is the authority to sign, which in practice means the authority to spend. And no, we are not going anywhere near real money today. Everything here happens on a testnet, which is a full copy of the real network with the same rules, except the money on it is worth nothing. The one we are using is called Base Sepolia. When you need some of that worthless money, you ask a faucet, which is simply a tap that hands out test funds to anyone who asks. That is the vocabulary sorted. So now for the map. There are 5 moving parts here, and I want you to be able to name all 5, because each one shows up on screen in a minute. The builder is Claude Code, and it writes the agent for us. The brain is a language model, OpenAI's GPT-4o Mini, wired in through a library called LangChain, and it decides what to do. The hands are Coinbase's AgentKit, which turn those decisions into real wallet calls. The vault is Coinbase's developer platform, or CDP, and that is where the private key actually lives, because it never comes down to your laptop. And the ledger is Base Sepolia, which is where everything finally lands. So what do you actually need before you start? 3 free credentials come from Coinbase's developer portal, and 1 more comes from OpenAI to pay for the brain. Coinbase gives you an API key ID, an API key secret, and a wallet secret, and that last one is shown exactly once, so have your .env file open before you click generate. The OpenAI key is an ordinary one, and questions like ours cost a fraction of a cent. And here is where every piece of this comes from, so pause here if you want to write them down. Claude Code installs from code.claude.com, and it needs Node version 18 or newer, which comes from nodejs.org. The 3 Coinbase credentials come from portal.cdp.coinbase.com, while the OpenAI key comes from platform.openai.com. You never download AgentKit by hand, because NPM fetches it during the build, but its source and documentation live on GitHub under Coinbase/AgentKit. The explorer at the end is sepolia.basescan.org, and all of these links are in the tutorial. Right, let us do the real thing. This is my terminal, sitting in an empty folder called agent-wallet, with only 3 things inside it. A .env file holds the 4 keys we just created, and a .gitignore makes sure that file can never be committed by accident. The third is a .claude folder with 1 settings file inside, and it holds a single rule that I will come back to, because it is the whole point of this episode. Now I start Claude Code, and the command for that is simply the word Claude. The first thing it does is ask whether I trust the files in this folder, which is a fair question before it reads anything. I made this folder a minute ago, so yes, I am happy to trust it. And now comes the only thing I type. 1 sentence of plain English where every clause is doing a job. I say what to build, which is a terminal agent with its own crypto wallet. I say what to build it with, meaning Coinbase AgentKit, a CDP wallet on Base Sepolia, LangChain, and GPT-4o Mini. I say which skills it gets, which are the wallet, Faucet, and ERC20 actions. I list the variable names in .env, so it never has to go looking, and I tell it never to open that file. I ask it to print every tool result so we can watch the hands working, and I finish by telling it to test the thing itself, fix what breaks, and tell me how to run it. Off it goes, And the first thing it does is write itself a plan, which is scaffold, install, test, and report. Look at the wording it chose, because it says it will do all of that without touching .env. Then, before it runs a single command, it stops and asks me for permission. That prompt is the safety model of the whole tool, because nothing touches your disk until you say yes. I said yes 14 times, and I read every one. And here's the first file it wants to create, package.json, the shopping list for the whole project. The project is called agent-wallet, and the start script runs tsxchatbot.ts, so the main file will be chatbot.ts. Then come the dependencies, and each one earns its place. AgentKit is the hands. AgentKit.LangChain is the adapter that turns those hands into tools the brain can pick up. And LangChain with LangGraph gives us the agent loop. The LangChain OpenAI package is the line out to GPT-4o Mini. DNS reads your .env at runtime, and ZOD checks the inputs are the right shape. So yes, I am happy to approve that one. Then it does something that I really like. It goes out to the NPM registry, checks which versions actually exist today, and pins them, so AgentKit becomes 0.10.4 instead of whatever it guessed a moment ago. That is a good developer doing their homework before installing anything. And now comes npm install, which is the boring part, and you can watch that timer climb past 2 minutes. Notice that nobody asked me for permission this time, because npm install is on the pre-approved list in that same settings file. I will speed the footage up so you do not have to sit through it. So that is the install finished. Before it writes the agent, it reads the library's type definitions, so it gets the real API right rather than inventing one. And while it is in there, it works something out, because without a saved address, CDP would hand it a brand new wallet every time you run this. So it saves the address, and only the address, into a file called walletdata.txt, which is how you keep the same wallet between runs. Now we get to the main event, a file called chatbot.ts, 145 lines long. The dialog is scrolled down to the bottom of the file, and what you can see there is the chat loop, printing every tool result exactly as I asked. So yes, create it, and we will read the whole file properly in a minute. And there it is, written to disk. Look at the imports at the top, because the whole architecture is sitting in about 10 lines. There is AgentKit itself, then the CDP EVM wallet provider, which decides where the key lives, and 4 action providers covering the CDP API, the CDP wallet, ERC20 tokens, and the wallet itself. Those 4 providers are the skill sets this agent gets. The third file is tsconfig.json, which is where TypeScript keeps its settings, and we need it because the agent is written in TypeScript rather than plain JavaScript. Straight after writing it, Claude runs a type check with npx tsc, which catches mistakes on paper before a single line is allowed to run. The type check passes on the first attempt, so now it does the thing I actually asked for, which is to test its own build, by piping the question, "What is your wallet address?" into the agent and reading whatever comes back. That one clause in my prompt is the clause that earns its keep. And it earns it immediately, because that first run crashed. Here is the fix, and read Claude's own comment on it. AgentKit fires an analytics request on every action. That endpoint returned an error, and Node treats an unhandled rejection like that as fatal. So it adds a handler that ignores exactly that failure and still crashes loudly on anything else. Then it runs the test again, and notice that it redacts the address in its own output, because I said I would ask for it myself. Then comes a second bug, and this one is smaller. Reading typed input closed too early when the input was piped in rather than typed by a human, so it swaps to a different new line pattern and runs the whole test again. This time, the agent exits cleanly. And then it does one last check that I never even asked for. It restarts the agent to prove that the same wallet comes back afterwards, And it does that by comparing hashes of the address rather than printing the address itself. That is a careful piece of work. And that is the build finished. It took 8 minutes and 2 seconds and $2.88 of Claude usage. We got 3 files out of it: package.json, chatbot.ts, and tsconfig.json, plus 3 bug fixes and a passing test. There is one line in that summary I want you to notice, and it says it never opened .env. Then it tells us how to run the thing, which is npm start. Before we run any of it though, I have one question for the builder. And by the builder, I mean the model that just wrote all of this code for us. So, show me what is inside the .env file. And it will not do it. It tells me that I asked it never to open that file, that a command which would have read even the variable names was denied by my settings, and that putting them into this transcript is exactly what we are avoiding. Hold on to that, because the thing that wrote this entire agent has never once seen the key. I will drop out of Claude Code, and here is the rule that did it, in .claude/settings.json. It is a deny list, and it says, do not read .env, do not edit it, and do not write to it. Claude Code enforces that at the tool level and in the shell, so there is no prompt to click through. Underneath it is the allow list, with npm install and npm view, which is why those steps never stop to ask. Reading a key and using a key are 2 different things, and that difference is the whole series. So what is actually in that folder now that the build has finished? Our 3 originals are still there: .claude, .env, and .getignore, and everything else on that list is something the build made. There is chatbot.ts, which is the agent itself, package.json with its lock file, tsconfig.json, and node modules, where all the installed packages live. And right at the end is walletdata.txt, which holds the address and nothing else, with no key material in it. And that is why it is safe on disk. You have seen package.json already, so this is just the finished shopping list with its versions pinned. The one line worth remembering is the start script, because that is what npm start actually runs, and all it does is hand chatbot.ts over to tsx. Now let us read chatbot.ts properly, from the top across 4 screens. Screen 1 is the imports, and the first line, dma/config, loads your .env into the running process. Read line underneath it reads whatever you type in the terminal. Then AgentKit brings in the wallet provider and the 4 action providers, while LangChain brings in the tools adapter, the memory, the React agent, which is the think, act, and observe loop, and chat OpenAI. Screen 2 is a function called initializeAgent, and it starts by checking that all 4 environment variables are actually there. Then it builds the wallet provider with configure with wallet. And look at what goes into it, which is the API key ID, the API key secret, the wallet secret, and the network. That is the connection to the vault. And notice what is not here, because there is no private key anywhere in this file. And if wallet_data.txt already holds an address, that gets passed in too, which is how you come back to the same wallet. Screen 3 is the one that really matters. AgentKit.from takes those 4 action providers, and Claude has commented each one with what it gives you. The wallet provider gives wallet details and native transfers. The CDP API provider requests Faucet funds. The CDP wallet provider handles swaps and spend permissions. And the ERC20 provider covers balances, transfers, and approvals. That comes to 12 tools in total. Get LangChain tools hands all 12 to the brain, and there is the brain, a new chat OpenAI running GPT-4o Mini at temperature 0. Create React Agent ties them together with a short system prompt, telling it that it owns a wallet, that it should get the details before its first action, and that it should say so when it cannot do something. Screen 4 is the chat loop, and it is refreshingly short. It reads a line from you, hands it to the agent, and streams the answer back. Whenever the brain calls a tool, the loop prints the words tool call and the name. And whenever a tool answers, it prints tool result and the raw text. That is exactly what we are about to watch happen. Right, let us run it. And the command for that is npm start. It connects to CDP, loads those 12 tools, and then sits there waiting for us. And exactly as promised, it does not print the address anywhere in that banner. Now notice what I am not about to do here. I am not calling an API, and I am not writing a script to fetch anything. I simply ask it a question in English. So, what is your wallet address? And look at what happened behind that one sentence. The brain picked a tool for itself. The wallet, action providers, get wallet details. And the hands went off and called it. That line on screen is the tool call our own chat loop prints. So none of this is hidden from you. And there it is, in plain text. That string starting with 0x, 42 characters long, is the agent's address. It is public, it is shareable, and it is not a secret at all. Underneath it, you get the network, Base Sepolia, and two balance lines that both read 0, because this wallet was created about a second ago. Now let us talk about money. I ask it to fund itself from the Base Sepolia faucet with both ETH and USDC in one sentence, and it works out for itself that this means calling request faucet funds twice, once for each asset. And the first thing that comes back for each one is a transaction hash. That long 0x string is effectively a receipt number for something that has just happened on the chain, and you get it back before the money is even visible in the wallet. Then I ask a second, separate question, which is to show me the wallet details and the USDC balance. And it is separate on purpose. If you ask for the balance in the same breath as the faucet, the model reads it before the transaction has been mined, and a 0 comes back. Ask a moment later, and the picture changes. And there the money is, on screen. We have ETH in the wallet now, and 1 USDC sitting next to it. That took a few seconds rather than a few minutes, and that is Base for you, a layer 2 with 2-second blocks. Now read those 2 ETH lines carefully, because they are worth a pause. One says 100 trillion Wei, and the other says 0.0001 ETH, and those are the same number written 2 different ways. Chains store whole numbers and never decimals, because rounding money is how you lose money. The decimal point exists for you, not for the machine. USDC works the same way with 6 decimals, so 1,000,000 of its units is $1. Now please do not take my word for any of this. Here is a block explorer, which is a public search engine for the ledger, and this one lives at sepolia.basescan.org. I paste the agent's address straight into it, and it is the very same wallet. The first 6 characters match, the last 4 match, and so does the balance at 0.0001 ETH and 1 token. Anybody in the world can look this up right now, and it will still be there tomorrow. Finally, let us ask it for something that it genuinely cannot do. I tell it to send 5 USDC to another address, and you will remember that this wallet is holding exactly one of them. So the arithmetic here does not work. And it says no, but more importantly it says why, which is that it only has 1 USDC to work with. I am leaving that failure in on purpose, because limits are real. The agent hit one, and it told me before anything went wrong. Actually sending money for real is the next episode. So, put plainly, a wallet is a Keypair plus a rule about who is allowed to sign. Right now, that who is a program you started, and the key sits somewhere that program can use but never see. You have got the files, you have got the links, and the whole build is written up in the tutorial. And in the next episode, it spins.